Okay, so let's discuss this problem number 2 in section 5.4. If you have watched the problem number 1, you might have already seen my discussion and my argument of choosing the right formulation because we said it's grow annually, it's per year. So we're going to use the formulation which looks almost identical to the formulation of compound interest, where the n is 1 because it's compounded yearly. Okay, so that's the formulation we're going to use, and you may go back to watch video for problem 1 to just make sure you understand the justification of that. Okay, the first part it says, what's the population in the year of 2002? And when is that? It is this many years, 1967, so it's 5-3. It's 35 years after 1967. So that's how many years you have to wait. That's your T. That's your choice of T. And also it says my annual growth rate is 8.1%, which is either you write it as 8.1% or 0.81. Either one works. So you are going to say, okay, at the year, which is 35 years later, I'm going to have my initial population, which is 7986, multiplied by the growth annually, which is 0.081, and I grow it for 35 years. Of course, you could take out a calculator, or you can simply say, well, this is conceptual what I'm supposed to be inputting as the estimated population at the year of 2002. And then let's move on to our second part of the question. It says, during which year? So let's be very specific. It's asking you what's the time, okay? It's asking for the T. Would the population, so you were given the population at the end, so we put back everything in. So my end population is given to me, it's 3924198. My initial population is 9786. I know it's compounded in this way. However, I don't know how many years I have to wait. So what I'm looking for, I'm trying to solve for the exponent. So hopefully you get familiar with this type of structure already. Whenever I'm looking for the exponent for a basic log structure, for basic exponential structure, I want to convert it into the log structure. So I have 3924198 divided by 7986, which is 1.081 to the power of t. Well, to make my life slightly better, maybe I want to simplify my numbers already. So let me say it's 3924189 divided by 7986. So what I have is, roughly speaking, 491.38, which is a little bit easier, shorter to write. So keep going. What I'm saying is I have this formulation, and I'm looking for the exponent. Therefore, how do we do it? We take log on both sides. So whichever log you feel more likely to do, you can just go ahead and do that. I'm not saying you have to choose natural log. You could have chosen log of base 1.081. I didn't do it because I simply think the number is not pretty. One thing you could have done is rewrite it into the corresponding log function. So it means t is a log with base 1.081 and then 491.38, and ask the calculator to do the calculation for you. I'm simply saying the base is too ugly. I don't like that. So what I did is I take log, natural log on both sides, and once I take natural log, I realize the exponent t can be thrown to the front. So it's t log 1.081. You have one number equals t times another number. So t is natural log of 491.38 divided by natural log of 1.081, which hopefully is something that you can calculate. So let's carry out my calculation on my calculator for give me just 1 minute. 491.38 divided by natural log of 1.081. So what I end up with in this case is 79.57. Okay, don't get super excited just yet. You are simply saying 79.57 years later, I'm going to reach the population you asked me to reach. But what's the question? The question didn't ask you how many years you have to wait. They ask you during which year it can achieve this population. When do I start? The started at the year of 1967, and you talk about 79 years after that. So your final answer should be 1967, add 79 year to it, and then you end up with 420. So this is your final answer, okay? So don't get super excited when you reach an answer which looks like the solution. You want to make sure you translate it into the correct structure, what the problem actually is asking you to do.